Hi again. So here's our example. We've got a few more complicated expressions regarding exponents. Now, when we have something like this, we always need to follow our order of operation. Now, order of operation tells us that we should do the brackets first. So let's simplify everything inside the bracket before we apply the exponent. So first of all, we're going to look at our coefficients. Our coefficient, we have 28 divided by 4. That gives us 7. The second one, we have x divided by x to the negative 4. So we're using our quotient rule, x1 minus negative 4. And same thing, quotient rule again. We have y to the power of 1 minus 6. And all of that is still to the negative 2. So I'm going to simplify my exponents here in the next row. I have 7x to the power of 5, y to the power of negative 5, all of it to the negative 2. Now we're going to use our power rule and take the power and apply it to every single base inside our bracket. Now inside our bracket, we have a base of 7, a base of x, and a base of y. So I have 7 to the power of negative 2, x to the negative 10, and y to the positive 10. But we can't leave our expression with negative exponents. So I'm going to make these positive by putting it into the denominator. The numerator, we're left with y to the power 10, and the denominator is 7 squared, x to the power of 10. In example number 2, we have powers that are being multiplied. 3x to the power of 9 times x to the power of negative 6, y to the power of negative 1, all squared. Let's simplify it by using our power rule. So I'm going to rewrite 3x to the power of 9, and I have x to the negative 12, y to the negative 2. And this is the 2 being applied to each of the bases in the bracket. Okay, next step, we're going to use the product rule to simplify my x's. So I have x to the power of 9 plus negative 12, y to the negative 2. We continue along. I have 3x to the negative 3, y to the negative 2. And we've finished, except we need to express it in such a way that we have positive exponents. So the 3 stays in the numerator, and the x and y base goes into the denominator with positive exponents. Now let's take a look at example number 3. Example number 3, we have a fairly large power, or a fairly large expression. When we look at this, we realize that our base, we have a negative 9 as a base and an x. So let's simplify by doing our power rule, all in the numerator, and then we're going to simplify our denominator. So let's rewrite this. Negative 9x all to the power of 12 times negative 9 to the 5. And then in our denominator, negative 9x to the 10th power. I'm going to rewrite this on the side just to show that I have negative 9 to the power 12 and x to the 12. So in our numerator, we are going to use our product rule to simplify. So when I have the -9 base, it's to the power of 5 or 12 plus 5, and I have x to the 12. All of it is divided by -9, x to the 10. Let's simplify again. So -9 to the power of 17, x 12, -9, x 10. Now this -9, I'm going to put it into a bracket and say that this is the same thing as -9 to the power of 1. So when I simplify, I have -9, 17 minus 1 because of our quotient rule, and x 12 minus 10. So simplifying, -9 to the 16, x to the power of 2. Our last example, we have -5 to the power of 0 times 5x squared all over 5 to the 9, x to the -4. One thing I need to remember is that this exponent 0 is only applied to the 5. So I'm going to write a note here. The exponent is only to the term directly in front. So in this case, the number that is directly in front is a 5, not -5, because we remember that -5 to the power of 0 does not equal -5 to the power 0. So what really this is saying is I still have a negative in front, and the 5 to the power 0 becomes 1. So let's rewrite -1 times 5x squared divided by 5 to the power of 9, x to the 4. -1 and a 5, we've got another base now. One of the bases is a -1. We have a base of 5 and a base of x. So when we simplify it, I'm going to leave my -1, and then I'm going to deal with my 5, 1 minus 9, and then I'm going to deal with my x's, 2 minus 4. So this becomes -1 times 5 to the power of -8, x to the power of 6. And we need to rewrite it so that we have things in the with a positive exponent. So our numerator, I have -1 times x to the power of 6 all over 5 to the power